This meeting is being recorded.
For problem 7 from chapter 3, we're told that we should use pKa values given in table 3.1 to identify the stronger base in each of these following cases. So we have here A through F, and we're given a pair of molecules for each example here. And I've already written in the pK values for the corresponding protonated form of our base. So these are all bases that are given, and we have some steps listed down here. So in step 1, we're told to protonate the base. So in that case, we would have acetylene here. And here, if we protonated this, we would have ammonia. So that's what you see written in parentheses there, the resultant conjugate acid to the base that's given. And then in step 2, we're going to compare pKa values from that table 3.1 of these conjugate acids. So for acetylene, we have 25, and for ammonia, we're given 38 on the table. So from that determination, we would know that the stronger acid is acetylene and the weaker acid is ammonia. And then from the pK, right? So that's how we determine the stronger of acids. And then whichever is the stronger acid, its conjugate base would be the weaker base. So we're looking for the weaker acid, right? So ammonia would be the weaker acid in this case, and therefore the stronger base. So this would be our first choice here. So we'll follow those steps again. We'll protonate our base. So here we have tert-butyl alcohol, and here we will have ethanol. So we go to the table, we see that ethanol has a lower pKa than tert-butyl alcohol. Therefore, it will be a stronger acid, and its conjugate base would be the weaker base. So this will be our stronger base. We have our tert-butoxide ion. All right, and then we look at our pair that's given in problem C, part C, and we have a protonated ketone if we were to protonate this, so +1 formal charge on that oxygen. Same thing will result with a formal charge here with hydronium. That results. So we go to our table, we see -7.3 for a protonated ketone, a pretty strong, very strong acid actually. And then we have hydronium, which is -1.74. So therefore, in this case, since hydronium is the weaker acid, we know that water would have been our stronger base. Next up in D, we have hydroxide, which goes to water when we protonate it. And then we have ethanol again when we protonate our ethoxide. So once again, we compare pKa's. The stronger acidic water would then be a weaker base than our ethoxide here. Or I'm sorry, the hydroxide would be the weaker base since water is the stronger acid. So our winner would then be the ethoxide. All right, so now we have E. We have protonation here would result in ethane, pKa of 50. Over here we have acetylene again. So we have a pKa of 25. Stronger acid for acetylene, so stronger base is our ethane here. And then we have our last problem here. The stronger base in this situation, we would determine again from our pKa. So we have a much stronger acid. If we were to protonate this, we would get HCl. Over here we get water. So the weaker acid, the higher pKa, the stronger base, hydroxide. So we see that hydroxide beats the chloride ion.